Good afternoon, and once again, welcome back to Aalto University's Internet Forum public lecture series. And as you very well know, our theme has been and will be during this autumn 5G. What do we all have to know? As you know, in our websites, you can find the recordings from the previous lectures, as well as you can follow either through Zoom or Panopto this live lecture what we are having today. As in previous lectures, if and hopefully when you want to ask questions or comments, you can put them in Zoom chat and I will share them to our lecturer. And once again, our students, please follow the code that will soon come to Zoom and verify your attendance in my courses, as you know from the previous lectures. Today, I'm very happy to have Jarno Niemelä, who is Head of Mobile Access Technologies at Elisa. Warm welcome to Aalto University.
Thank you, Jarno.
And the title of today's lecture is 5G End-to-End Solutions from Operator Perspective. If I may, Jarno, before you start, ask one question. How big thing 5G is in Elisa at the moment?
Yeah, I think I have to say that it's one of the biggest thing in Elisa, yeah. Especially from a technological evolution perspective. We foresee that it enables new services in the future, and of course, like continuation of mobile broadband technology from 4G now to the 5G. So I think it's one of the most important thing in Elisa.
Actually, I have asked the same question from some other lecturers before you, and they have said more or less exactly the same thing. But I will continue one other issue, one other question. How tough is the competition in 5G between different companies at the moment?
I think, okay, within Finland, obviously, that I'm coming from, so competition is tough.
Yeah.
We have foreseen in a way that already in 4G era, also before actually 4G in 3G era, yeah. we foresaw that the competition is getting heavier and heavier. Of course, for consumers and for our corporate customers, it's good because it's pushing down the prices. But those obviously for us that we have to stay out on our toes, yes. Naturally with the competition, which is very tough.
Hey, warm welcome to Aalto University, and we look forward to hear your lecture. Please.
Okay, thanks again. And hello everybody there on the other side of the broadcast. Like Jarno mentioned, my name is Jarno Niemelä. I'm heading the Mobile Access Technologies in Elisa Finland. And today I'm going to talk about 5G. 5G from more or less like end-to-end perspective. And I want to outline a few items from technological perspective, and obviously then from say 5G specific perspective, like standalone, which is kind of the natural evolution of 5G, enabling the service evolution. And also I'm going to tackle a little bit about the slicing, how we foresee that slicing is one of the key technologies in the 5G evolution. Then I want to address also something about automation, how we kind of tackle the complexity of mobile communication systems as of today. So really glad to be here with you, and hopefully we'll have a very good session for us. I will talk a little bit about generally about Elisa, how we are positioned at the moment, and also what kind of evolution or path we have had in the frame of 5G. And I'm also linking this to 4G evolution, as we foresee that especially today 4G is still quite an inherent part of 5G mobile broadband, and also the service offering that us as an operator have. Then those more technical items on the technological perspective. So we have seen in the previous lectures that majority of 5G is obviously something that we observe in the radio access interface. And I want to give a little bit more broader perspective on that one. So I address also some parts of the terminals. I address obviously the radio access network, which we heard in the first lecture series from Nokia. That was quite a very comprehensive insight to the 5G as of today, and also the evolution. And I will actually spin this towards the core network. I'm going to look a little bit about the backhaul connectivity. So basically the connections that are arriving towards the radio access networks, a little bit the aggregation network behind that one, and also finally then ending to core network that is basically providing further connectivity towards other networks in the mobile communication system. And I will end up this, like mentioned, I will end up my presentation on the in a way some key observations that we have observed also before 5G era, and something that we are really proud of in Elisa. So if we look at the Finnish market at the moment, we kind of foresee and we have seen that Finnish consumers, they are rather data hungry, and on average we have quite a huge consumption of the data on a monthly basis, and a little bit depending on the customer segment, there are some certain figures that are even spanning close to almost 40 gigabytes on a monthly basis per subscriber. And if we look at the European average, that is clearly below 10 gigabits per user per monthly basis. And I think one of the key drivers for this kind of a consumption has really been the fact that Finland, we have quite a huge country with long distances. So fiber penetration is not so wide, especially in the rural areas and sparsely populated areas, and people there and also in the cities have adopted mobile broadband as their only home broadband connectivity. And this is obviously one key reason why we have today quite a lot of data originating from the network and used by our customers. And this is where we look at figures like 36% or 1/3 of households that are using mobile as their primary connectivity. And I would say that there are obviously few reasons for this one, not only the innovative habits and availability of different kind of connections, but also the regulatory landscape in Finland has been quite favorable towards explosion of mobile data. And as we saw from Traficom, we have a quite wide set of frequencies available, and I would say that perhaps we have one of the most best situation in terms of frequencies on a world basis, and this obviously is that we have not only the low frequencies allocated for operators in Finland, we have also the mid-band frequencies. Now the 5G frequency in 3.5 gigahertz, and also we have a very good example of very high frequencies, 36 gigahertz frequency that has been allocated for operators in Finland. And In the background, obviously, there is an active dialogue between stakeholders. Our regulator wants to have an early adaptation of 5G, and clearly in the future, there will be more frequencies designated or allocated for 5G. And with those frequencies, then obviously we can continue the story of having quite good connectivity in the mobile broadband networks. And so that we wouldn't like to discard the fixed access, that is, for example, in Elisa, also an important thing. We are, of course, investing a lot into the fixed access as well, mostly on the fiber connectivity. And our regulator is actually taking nicely this kind of technological neutral approach for us, so we can actually offer with mobile connectivity or then with fixed access connectivity, mobile broadband connections. And in 5G, we actually at Elisa started already a few years ago. We made demonstrations in the pre-commercial networks back in 2016 already, and little by little, when we actually were able to obtain still pre-commercial devices, both from the network side and the terminal side, we were able to obtain or start to learn the 5G and what is actually the implication of 5G for Elisa. Then 2018, we opened the first network, and a few years ago, 2019, we went live with a commercial 5G, meaning that we had subscriptions, we had the terminals in our shops for our customers, and we had the network, fully functional network as well. And ever since that one, obviously, it's been a learning path. We try to learn from different aspects, as with the previous technologies, and one of the key things in the learning is obviously that we also test and kind of stress the technology, that what kind of a performance the technology can actually offer for us, and then how we can use that to help our customers with their connectivity. And example of this one was actually made last year, where we had the demonstration on the millimeter wave or 26 gigahertz frequency, and we were able to obtain up to 8 gigabits per second connectivity. And I think it was very well put from Harri from Nokia that okay, as an individual user, I don't have an application that I could consume 8 gigabits per second connectivity. But we have to think it from the operator perspective. It's that it's more reflection of a network capacity rather than a single user bit rate or maximum bit rate that he or she can actually obtain. And that this is actually the same thing that we are doing with 5G. So instead of talking about peak rates and what is in a way the technological capability of a certain system, we have to think from the network perspective and think as a capacity offering for our customers. And as of today, we have let's say more than 100 cities as our competitors have as well. I think all of us, we are kind of building with our own strategies, obviously starting from the cities, and we all can actually have today already the 5G service offerings and the availability of network, mostly in the cities and little by little in the rural areas as well. And this is actually what happens typically with a new technology, that little by little we start from the cities, and then it takes several years actually to build the network to reach your rural areas and sparsely populated areas as well. And as of today, I think we are around 70% of population coverage with our our 5G offering. And of course, what we want to provide for our customers is a high quality network with high quality end user experience. As of today, there are a lot of terminals available in the shops, and I think all of us, the local operators, we have announced that more than 50% of the new phones are already 5G capable phones. So in a way, the story continues, and there will be new features, and the terminal availability will increase in the future as well. Extensive coverage, obviously complementing and increasing all the time. We know that it takes several years to, in a way, have a certain rollout and have a certain population coverage. And typically after that one, it turns from a coverage towards capacity tackling. Of course, we want to use, in a way, the latest technologies. We have all the, in a way, the main radio access network players. So we have a kind of multi-vendor strategy there. We are able to compare from different aspects the radio vendors. Also in the core network side, we have a multi-vendor strategy, and also in the transport connectivity side. So it kind of putting vendors in the competitive landscape and taking from each of the vendor the kind of the best possible technological advantage. And then the final thing, what is one of the key things in the 5G evolution is obviously our automation. We have been quite active in that frame. We are using automation in our daily operations quite heavily, and actually later in the presentation you will see some examples on that one. Where we tackle a little bit on the radio access network automation aspects. So, like I mentioned, I like to bring a little bit broader scope for what we see as in 5G. So 5G for us is obviously the high bit rates and high rate connectivity and reliable networks that our customers are seeing when they are using the networks. But that's obviously let's say a small piece of the whole entity. And I will now go through a little bit that what kind of 5G related activities we have in different technological regions or different technological areas when we talk about 5G connectivity. So terminals and subscriptions are obviously in a way something that customers and the network users are able to see. We have several hundreds of thousands of 5G capable terminals already today, and that figure is obviously increasing all the time. We have subscriptions. They are pretty much following the same philosophy that we have for the subscriptions already from early 4G era. So speed tier pricing, and in the frame of 5G, we are able to see in our offering 300, 600, and then 1000 megabit limited connectivities. And obviously these figures will increase in the future, and I will address also later on a little bit that what kind of new attributes are actually expected from the terminals actually very soon in the network evolution. Then what happens in the radio network is obviously something that we are building the network all the time, 70% of the population coverage. And as was explained very well by Harry from Nokia, is that 3.5 gigahertz is kind of the main 5G frequency. We have in Finland at the moment 130 megahertz of spectrum in that particular frequency band. Although we are using at the moment in a way the basic 100 megahertz setup in 5G that is obviously offering us quite nice connectivities. And in a way, the end user through bit rates are around, let's say, peaking to 1 gigabit. Theoretically, we could go also further on that one. And then in the non-standalone of the network operations, we are actually using, or the technology is built such that it's using also the 4G for improved coverage and improved bit rates. But what happens behind the radio access networks? So obviously those sites that we have roughly 10,000 in Finland, those sites need to have a connectivity towards rest part of the network and further then towards the services that they are using. And this is what we call backhaul. For us, it's mainly building a fiber connectivity with 10 gigabit speeds, so that we are able to offer those gigabit level connectivities for base station sites. And obviously there are a few locations where we don't have a fiber, so then the microwave links are there, the technological solution. But obviously the bit rates in the microwave connectivity, microwave technologies are sufficient to support 5G and also its evolution. And at this point, I want to bring up one very crucial role of or component of 5G, and it's related actually to synchronization. So as we know that 5G in that 3.5 gigahertz frequency is actually based on time division duplex technology, meaning that we have a constant switch between downlink transmission, so basically from the base station towards the mobile, and also we have a dedicated slots from mobile towards the base station, and this is a timely division duplex system. And it requires very heavy synchronization, and this transport network, backhaul network, needs to carry this synchronization. That is actually of the order of nanosecond level. Then behind the transport or the backhaul connectivity, we have kind of the aggregation network. So we aggregate those backhaul connections towards a fiber optical network, deploying different topologies there. But this transport aggregation network needs to be obviously with very high bit rates. So we talk about 100 or multiples of 100 gigabyte connectivities there. And the attributes for this network and the elements of this network needs to also support this synchronization. Then we are actually approaching to the edge of the network in a sense that we have typically the data core network and also the voice core network there available. And then obviously those network functions and the elements will then provide connectivity towards other networks. For example, other operators' networks, internet connectivity, and so on. And here, 5G is actually something that is relying today for the 4G core network technologies. However, we have been demonstrating already last year, and we are very heavily now testing and commercializing also the 5G core with its service portfolio. And in the following slide, we actually see a little bit more on that one. Then there are a few items that are present basically in every single domain that is handling the connectivity. And network management is something that spans all over the technological stack, and typically it's consisting of systems that are designed to control certain technologies and also certain vendors. And this is where we actually implement not only the in a way, the basic monitoring systems, but also orchestration. That will be one key thing in the 5G evolution. We deploy the automations to support, in a way, the actions that we need for network operations. And also in this part, we actually deploy very heavily end-to-end of the security aspects. So in a sense, we have mechanisms that we make sure that the network elements, whether they're in the radio access, whether they are in the transport or the core network, there are certain security standards in the implementation. And as an operator, we obviously want to deploy a lot of processes on top of how we use those technologies, so that we are seeing a secure connectivity from our customers towards their needs. And finally, we have, in a way, the business support that is mostly a mediation layer from technical activities, technical domain towards the business domain. And for example, here we have the subscription management and for example, different set of systems that typically operators have quite a lot there. And all these elements here are somehow or another subject to 5G. And we will look at also examples later on how, for example, slicing is affecting on those different technological stack and elements. Now I want to address, after this kind of bringing the end-to-end connectivity and the view of the network, I would like to address in a way how we see the service evolution and what is the enabler for the service evolution. And I think it was very well addressed in the previous lectures by Johan from Ericsson and also the colleagues from Telia, that private networks and this kind of applications for vertical industries, they are very inherent part of 5G service evolution. And now, as of today, we talk about this non-standalone technology. We are able to obtain, let's say, hundreds of megabits of speed in the downlink direction, and also some tens of megabits connectivity in the uplink. We have a certain latencies. Harri was mentioning about the evolution below 10 milliseconds. Nowadays, we on average are around 10 to 30 millisecond region. However, here the core network is still 4G, so we have basically the non-standalone of the network only operational in the radio access network as 5G technology. Voice connectivity is based on voice over LT connectivity, so it's an IP-based talk mechanism, a communication mechanism, but it's still one of the main things that is driving the connectivity today. From the data perspective, it's inbuilt in the system that devices are able to use 5G and 4G simultaneously, and this is how they are able to tackle, or let's say 5G is able to use 4G as an underlying technology. And this is obviously good for operators, because all of us, we have built already our 4G networks for some time being already. Then a little bit more on the quality of service or quality of experience. And this is where 5G standalone is clearly distinguishing from non-standalone technology. And there has been quite a long mechanism in the technical specification work for this kind of a service level differentiation. There has been mechanisms to support different bit rates for the users, how to have an end-to-end view of the connectivity, and so on. However, this mechanism has been quite complicated, and it hasn't really boosted towards operator usage, at least to its full extent. But there is mechanisms how we can, for example, deploy service level differentiation already in 5G non-standalone mode. Terminals, as I mentioned, they are 5G capable as of today, and obviously have a very good performance, and also in the 4G domain. And for example, terminals in the mid-band price, already also in the low price end, are able to support several 4G carriers. Speed tiering we went through already, and also the customer benefits that we foresee from non-standalone technology of 5G. Then standalone is representation of a service network. So obviously in standalone mode, one of the key things is that then our customers, when they have a standalone subscription and standalone terminal, they are able to use only 5G frequencies. And for these 5G frequencies, as we have been learning towards these lectures, we are using 3.5 gigahertz frequency, and then with the combination of some lower frequencies like 700 megahertz or 2100 megahertz. We are able to see, of course, a significant bit rates there, but nevertheless we a little bit lose towards the non-standalone. And this will obviously change in the frame of a network evolution, where operators are starting to take 5G connections more and more 5G frequencies into their usage. Core network is a 5G, as we were learned, and also the voice over new radio will be there eventually available for our customers. That is, in a way, the 5G native mechanism for speech delivery. And in the quality of service or experience domain, we have I would say the biggest differentiator between standalone and non-standalone mode. And that is kind of a mechanism that is enabled with the technology called network slicing. And the key thing is that in the network slice, when we have the subscriptions defined and we have users connecting towards the network, then the radio access network is actually aware that which slice is being used. And this is kind of the biggest difference between standalone mode and non-standalone mode. And also this is one of the big enablers for operators to start providing slice-based services where we can differentiate between different use cases. And in the previous lectures, we have seen that there are a lot of use cases in 5G available, and those use cases will eventually be deployed on top of separated network slices. And now today, the subscriptions, we don't yet have the subscriptions. We are in the commercial mode, but not yet offering standalone for the subscriptions, but pretty soon we will on that one. And this is obviously where we foresee that our customers are able to benefit more and more from evolution of 5G technology. So if we look at this slicing, we come back to the same figure, basically, that we were learned before as a technological stack that is required for the 5G. So if we look at that, what slicing is impacting, how slicing is actually impacting towards different interfaces and elements. So technically, slicing can be defined such that it's the kind of the ability to create virtual networks within the same physical network. And while saying that one, each slice can then have a different kind of a service level attributes, and we can kind of target the exact capacity. We can target, for example, guarantee on the bitrate and the connectivity, we can address the low latency applications as well with the help of network slicing. And implications obviously are in every single technological domain. If we look at the terminals and the subscriptions, we know that they have a certain capability to support even simultaneous slices today. However, the subscriptions obviously need to be defined such that the slice can be used from the network. In the radio access, like I mentioned, we have awareness of slices, and this is exactly where we can basically allocate capacity with more gradual resolution towards our customers. And obviously this resolution is quite tight. We talk about, let's say, millisecond level of activities in the radio access network, and those are kind of cumulated then to user experience when they are using the slices. Also in this case, we can actually address the mobility aspects. For example, if we have a fixed wireless access connectivity in the network, it can use and it can be optimized differently as, for example, the vehicle users or then the smartphone users. Or even in a case of private network, this kind of IoT users can be using different attributes to support from the mobility perspective. Then in the backhaul, I would say it's a way of service differentiation. We can use, for example, certain virtual local area networks mappings, actually both in the backhaul connectivity and also in the transport aggregation network connectivity. And this is where actually typically the capacity bottleneck is not there. It's basically on the radio side, but nevertheless, in order to have this kind of end-to-end view of the network performance, not only from the radio, but also on the transport side, on the core network side, it's very useful that we kind of create end-to-end visibility for a slice. Then in the core network perspective, now I'm talking about 5G core network only. In the standalone mode, there is an technological specifications and implementations that support network slicing there, and pretty much the same situation as with transport network. Typically, core network is not the bottleneck when we talk about the capacity of the mobile network, but it's rather a mechanism to isolate the services and so forth, have a more comprehensive visibility on a slice level, so that, for example, the slice what is connected towards the fixed wireless access have certain attributes, and then compared to the, for example, the IoT slice, so they might have different service level requirements, and therefore it's kind of crucial to have an end-to-end slice connectivity. And also network management and then the business support systems need to support network slices. We need to build up monitoring, we need to build up the orchestration for the slices and also the automation in the future. We start obviously with, let's say, limited set of slices, but eventually we foresee that when the 5G service evolution will actually continue, there will be more and more demand for slice level automation as well. And in the business support system side, we need obviously the subscriptions that are attached to these slices, and also this is a mechanism for us to have let's say, at least guarantees and preconditions towards further service level agreements. So again, standalone was something that was like an end-to-end. 5G as such is end-to-end, and we foresee that the slicing is also end-to-end solution in the 5G evolution. Then I want to address the other topic that I had in mind about the automation of a network, and I want to highlight a few aspects. what happens into the planning side of a network and what happens in the operations and also in the optimization of radio access network. So now I'm leading a little bit the scope. I'm talking about the radio access network only. And we have started, obviously, in the case of 4G networks, addressing the mobile network capacity. And obviously, as an input for this capacity demand, we have several different kind of attributes. We need to be aware of our customer base. We kind of need to be aware of how they use the network. Of course, demography, how they have actually distributed within our network. The status of a current network, that has an implications where we deploy the capacity, and obviously then the forecast. And these are kind of a technical attributes there in the background in the decision making. And then, of course, we look at the future potential of business from the business side, and also how the competition landscape is looking like. So kind of several inputs from a planning perspective, and with the help of this information, basically with the help of automatic analysis from different variety of sources, we end up with the kind of a network target state. And this target state is kind of representation of high-level planning. So we talk about the very high-level planning there on the on the left-hand side of, this high-level planning, the network planning in the radio access network, is basically realizing towards site selections for our construction program. So this is kind of where we build up the network rollout of the network. And each of the network elements in the radio access network are obviously realization of the sites. And I think in Harry's presentation we saw very nice pictures of typical 5G sites, a lot of radios, a lot of antennas there in the mast or even in the rooftops. But this is where we actually perform the kind of the radio frequency planning and set the antenna directions and the transmit powers correctly there. And what happens after that? We have parameters. We have radio access network parameters, and then we have a transmission parameters. And kind of in this phase, we already are, from operator perspective, defining a network, defining a site solution such that we are able to take that site into use. And here on the right-hand side, you will see in a way the processes, site integration, site provisioning, and site validation. Site integration is such that we actually make our network ready for the site. Site provisioning is that actually the site is being taken into use, and validation is something that we typically perform very after the site has been provisioned towards the network. And each of the phase is obviously feeding the other phases in this process and has a certain different kind of optimization levels. And these optimization levels and also the phases what we enter here, we typically have a very extensive level of automation. And this is actually enabling us to have a full concentration on what is actually crucial and rather than on the trivial manual tasks. So this was one example of how we use automation in the run operations. The other example is what comes to the operations and the optimization of a network. And here on the left-hand side, you will actually see, in a way, how we deal with network operations as of today. And this is involving also the 5G, but also all the legacy technologies. We have actually 100% of the alarms automated, in a sense that we don't use any human beings to monitor the alarms from the network. But we have kind of built the logic for the monitoring, and then we are kind of seeing the results of automated actions that are performed based on those automated alarm ticketing. And actually, 90% of our network operations and ticketing actions are actually automatically resolved, meaning that 9 out of 10 cases we have automated resolution for a certain challenge in the network. It can be malfunctioning device, it can be some software bug or something like this. And only 10% of those cases are not being able to automatically resolved. And obviously those 10% are typically representations either of new problems in the network, or then that there are physical problems, for example, broken antenna or broken cables in the sites. So this is actually a very short process flow that how we actually address these operations. So just to put it simply, we have certain alarm originating from the network, and we make a distinction whether we have a known pattern or we don't know the pattern. If we don't know the pattern, then we kind of try to manually find the root cause. We will basically design an algorithm for it and develop the algorithm and deploy it also in our operations. And then it becomes an automated use case. And of course, I'm going through this process. I actually make it sound very trivial, but it's nothing but trivial, but it requires typically very deep expertise of a network. And as of today, we have hundreds of these kind of use cases operational in our network. Typically, they are vendor-specific, then they are technology-specific, and they are addressing certain parts of the network. So we have, let's say, variety of those kind of automated actions and use cases in our network. And of course, 5G has, as a new technology, been there. We didn't have any experience on 5G before we started, but little by little, we have been improving also the operations in our 5G networks. The other example is closed-loop optimization. Typical cycle in the optimization is that obviously you need to have a certain data as an input. You kind of monitor that data. You analyze the data. You try to build a certain logic from a certain perspective. For example, 5G power saving. You try to build up a logic for that one, and then you kind of act and deploy this kind of a logic towards your network. And these are addressing typically different radio resource management activities. For example, accessibility of the network. So we want to maintain the accessibility towards the network as high as possible, even though we have a heavy rollout ongoing and the network is changing all the time. Mobility and load balancing are very crucial in the case that we have a quite complex network. We have several frequencies available, and each of the site is typically a certain representation. It's different than the other side. So we know that with the help of mobility and load balancing functionalities, we are able to tackle and optimize the user experience. And then the third one is something that we look at from the efficiency perspective, both from the technical efficiency but also the cost efficiency. There are certain parameters in 5G that we can use to optimize the network. For example, the antennas and the beam-forming patterns of the antennas. Those what we can optimize. And also, as of Elisa, we have been paying a lot of attention on the energy efficiency of the network. So we can kind of use different kind of approaches when we save the energy in our network. For example, we can start lowering the transmit power levels if we see that it's beneficial from the network perspective, and also we can, for example, occasionally take certain frequencies out of use for a certain time of a period, and hence save the energy. And With the help of these kind of mechanisms, automated actions, I would like to pinpoint a few examples from the results that we have been observing with the help of this kind of automation of network operations. And you can see there on the left-hand side that we have been increasing the amount of daily actions quite heavily. I think the transition point is more or less in the case that we started to deploy more capacity in the 4G network, and as you can see, in a way, the increase in the daily actions what we do today, it's increasing all the time, and it's quite heavily. So this is the result of our network automation algorithms. Simultaneously, from a customer perspective, we see that for the past 10 years, we have been able to reduce the amount of incidents in our network, so in a way more functioning cases of a network, and we have a reduction of 73% of network incidents compared to what we had 10 years ago. And this is obviously the help of our automated algorithms, and by our definition, we have the ability to kind of have a preventive actions of an fault. So, for example, if with certain key performance indicators that we are acquiring from the network, we foresee it and we predict that a certain malfunctioning will happen in a certain network element, so we take a preventive action on that one. And this is where we are actually nowadays, so we are actually at a very high level, but obviously we have to remember that the technology is evolving all the time, so we need to stay on track with the technological evolution, and for example, in the future, have reactions, for example, on the standalone and also on the slice levels when we deploy the network slicing. So, in a way, the results are, I would say, pretty good, or even let's say magnificent. And I think I'm proudly looking at this one because I've been like 10 years in Elisa now. So over this period, the amount of traffic has increased by 40-fold, so 40 times higher traffic than it was in 2011. And we have been able to maintain the same cost level in general from the capital expenditure point of, and also from the operational expenditure point of view. And we have an intention to keep this going on also in the future. We have had 0 critical major incidents in our networks for the past 5 years, and again, we, as from the technological perspective and from the network production perspective, are basically doing a lot of things that we prevent those activities, and I just hope that they will also keep that way in the future. And as a result for us, it's been more like a cultural change. We have actually given up of traditional network operations center already some time ago. So there are no humans looking at alarms that are originating from the network elements, but rather our engineers are concentrating on building new algorithms, building new automation use cases, and also concentrating more on the service level operations rather than network level operations. So these kind of examples from 3 different angles, from the planning angle, from the operations angle, and from the optimization angle, is something that we have already deployed in our 5G operations, and we want to keep going on that one in the future as well. So if I summarize in a way the activities and the contents of the lecture, actually what we have seen is that 5G has implications pretty much in every single technological stack. From the network perspective, and also from the customer device terminal perspective, from the subscription perspective. So 5G spans all over the technological stack. Now 5G service evolution will be enabled by 5G standalone. It enables new services which we have seen in the previous lectures, especially for the vertical industries, very heavy industry machines that we were able to see use cases, for example, from Telia, private network sector, and so on. So networks will be more and more ready to serve these kind of vertical applications and vertical industries. Slicing is one of the key mechanisms to deploy this one. Our operations, they have been quite well triggered for this kind of telco scale operations or telco grade operations where we are used to serve consumer customers. Obviously, there has been corporate customers in all the operators, but now I think 5G is bringing something new, and slicing is something that we can enable in our network in order to be ready for those new 5G use cases for the vertical sector. And in Elisa, we are proud of our automation activities. We have been starting to commercialize also these kind of the knowledge that we have in the frame of automation, and we keep continuing this path as we foresee that the future is nothing but simple. Our networks are getting more and more complicated, the terminals are becoming more and more complicated, and the services eventually are also becoming more and more complicated. So we see automation as one inherent part of 5G evolution. Okay, so that was from my side.
And I have to say also that I really liked that you referred to the other presentations what we have heard during this autumn in this public lecture series. And actually I have to ask you the same question that I asked to Harry from Nokia. That okay, you are with some companies you are competitors, but then on the other hand, how much you cooperate also with your competitors in this field?
Yeah, I think one of the, let's say, the biggest area and the region where we are cooperating is the regulation and frequencies.
Yes.
And especially, okay, I'm kind of handling the frequency side within the Elisa, so I'm quite heavily in cooperation when it comes to the frequencies. And okay, frequencies is one part of the regulation. We know that they are very heavily regulated, but there are also other aspects. And I think in those areas we are cooperating quite a lot between our competitors.
Very good. Martin is writing here in chat, great and informative lecture regarding the implications of slicing for consumers. Will the network will be able to fast lane and slow lane users in a great resolution and very small incremental differences in sliced lanes.
This is something that technology is enabling for us. So as of, let's say, I have to admit that in the first phase, we don't have such a dynamics, for example, fast lane and slow lane for the consumer customers. Slicing is something that is being built now. It's something that has been specified just like a few years ago. It's still pretty new. None of the operators are very widely using it still today, and I think it will be a learning path towards the future. And we see already now that there are some technical components also in slicing that will eventually enable us have also more dynamics there. So not only the static configurations, but also the dynamic configurations, and exactly, for example, based on the need of a certain customer.
When I'm thinking about our students in Aalto University and all the other places as well, what would you say from the research point of view? What are the biggest challenges what in 5G reality, for example, in your job, you would like to know more?
I think, yeah, Harry was covering some parts of 5G advanced, and I think later on we will see also 6G.
Yeah.
I think we saw also the 7G already. That is something that is I think it's a continuous evolution. Yeah. There are certain research directions, how to use even higher frequencies, how to use even wider spectrum, and so on, from the technological perspective. Yes. The other aspect that I actually brought today is something that is related that, okay, as an operator, we are adapting the technology and we operate the technology. So there, I think a lot of items should be actually in the research domain, concentrating on, for example, fully autonomous networks. Mm-hmm. How do we run those networks today because and in the future? Because now we will get more frequencies, we will get more complicated networks, we will have more services available for our customers. So eventually we need very autonomous networks, networks as well. And this, of course, where we talk about how to apply, for example, machine learning, how to deploy and apply different artificial intelligence approaches and so on. So I see kind of two different angles. Technology is something that needs to be continued, but also the operational side, there are certain research aspects as well.
Good point. Good points, and I really like the final point, the last point in this summary slide. Operational complexity can be tackled with automation, and from the security point of view, what I have learned during my career is that complexity is usually the biggest enemy of the security. So very well said. Another question. How much wiggle room is available when planning the radio resource parameters in terms of transmission, power, and direct nationality? Is it a blunt instrument, or can you tweak very small parameters in the quest of optimization?
Yeah, that's a very, very good point, and I think the whoever made the question has really seen, in a way, the practical limitations what we have also when we deploy the network. So in terms of radio access network and transmission access network parameters, obviously we are tied with, for example, certain site locations. We all like to use, in a way, that's a physical asset for us, of us have a certain mast location, that sort of. Yes. And this is bringing border conditions, how much we can actually optimize, for example, the network layout. In the parameter domain, we can do something for the transmit power, or I would say this kind of a soft parameters is something that we can play with. But when it comes to the physical configuration of the site, so that's very rarely where we are having, let's say, majority of the room. Yeah. It's more or less certain constraints what we have there, and those are typically quite severe constraints.
Yeah. Hey, what about the security? If I come a little bit back to cybersecurity and all the other security issues related to 5G, how big role that plays in Elisa?
It plays a role. It plays a role, and like I mentioned, we are obviously relying that those security functionalities, for example, what comes to 5G, they are better than was in 4G. So there are mechanisms and standardized mechanisms already how the elements themselves are more secure. Yes. However, I see that operators, we have bigger role there because we have to build the whole technological stack from the radio towards transport, backhaul, core network, such a way that we kind of have a processes that we look not only the physical security, but also in a way the cyber security aspects. And this is where we are kind of applying different kind of regulations, obviously. Mm-hmm. We have those aspects. We are relying on the multi-vendors, so we will get always, in a way, apples to apples as a comparison. We are monitoring our own network and operating our own network. So these kind of processes that we have kind of established so that, in a way, the security, both physical and the cyber security requirements are fulfilled. There is a small but there. It is, of course, something that we cannot affect is the behavior of the user or the terminal side. Obviously, there is inbuilt secure connections from the terminals towards the network. network, but in a way, how to address that is something that we do internally. So there's a lot of trainings from security aspects for all the Elisians. So that's why we have to address the technological area, the process, and also the people.
Absolutely. And hopefully in this whole technological megatrend, we are not going to forget the people.
Yeah, exactly.
And the humans. Hey, thank you very much, Jarno Niemelä from Elisa. It was an excellent presentation, as we heard from the feedback as well, and very, very good points. And it was our pleasure to have you in Aalto University.
Thanks for having me here.
Thank you.
Thank you.
And thank you very much, all the listeners listening this live or the recording afterwards. We will continue actually after 1 week. So next week our title is Digitalizing Business with 5G, and Sami Häggman from DNA will give that lecture. So thank you very much and have a safe week. Thank you.